As an electronics engineer, switching supply components are something you see every day. Each part has its own role, and following certain rules they can form many types of power supplies. Beginners may feel overwhelmed by the crowded components, but once you know their functions and how they're arranged, most switching supplies are very similar. In this video we'll break everything down, lots of useful info, so remember to like and save. A switching power supply is generally divided into 6 sections. Input rectification and filtering, output rectification and filtering, EMC section, control section, feedback section, and the transformer. Most supplies use roughly the same parts in each section. First is the EMC section. At the input, it protects and filters noise from bottom to top. We have the fuse, move, NTC thermistor, X capacitor, and common mode choke. The fuse blows when excessive current appears, protecting the circuit from damage. The move clamps voltage spikes during storms, absorbing surge energy to protect downstream components. The NTC thermistor has high resistance at room temperature, so it limits inrush current when power is first applied. As the supply runs, it heats up and its resistance drops. The X capacitor connects across the AC input to suppress differential noise, and a discharge resistor is added to prevent electric shock. The common mode choke blocks ME from radiating outward. There's also a Y capacitor between the input and ground, working with the choke to reduce common mode noise. Next is the input rectification and filtering section with the rectifier bridge and electrolytic capacitor. The bridge turns AC into DC. The electrolytic capacitor stores energy and smooths the output. Now the control section, which includes the controller, IC, capacitors, resistors, and more. The IC contains the switching transistor and logic circuitry. In high power supplies, the switch transistor is external and mounted with a heatsink. The control section is the brain. It drives the switching frequency and processes feedback signals. Next comes the transformer, which steps down the voltage and provides isolation. After the transformer is the output filtering section, with diodes and electrolytic caps. The diodes provide rectification through their one-way conduction. Finally, the feedback section includes the optocoupler and the TL431. The optocoupler sends signals using light, allowing communication across the isolated transformer. The TL431 has a precise reference inside and compares it with the output voltage to check whether the voltage is correct. That's a quick overview of each part of a switching power supply. If you want to know how these components work together to regulate voltage, leave a comment below.